7-5 sum and difference formulas. So when we talk about sum and difference formulas, these are different formulas than you've used before. There's a new formula sheet. The first one is actually going to just use the regular distance formula, which I talk about a little bit. It's like the Pythagorean theorem. It's like c squared equal a squared plus b squared, and so c is the square root of a squared plus b squared. Except the difference is you'd say a is like x2 minus x1 and b is like y2 minus y1. And so that's how it's related to the Pythagorean theorem. The other ones you're going to need to know are, you're going to use your unit circle on some of it, and you're going to use these sum and difference identities. Now, when we talk about sum and difference, that means adding and subtracting. So you'll see these in your notes, but basically, if it's the sign and it's plus, it goes sine, cosine, cosine, sine. So that order, because it's different between sine and cosine. And then if it's a plus, then this stays a plus for the sine formula. And if it's minus, this stays minus for the sine formula. On the other hand, for cosine, it's different. It goes cosine, cosine, sine, sine, opposite sine. So in the formula, this is plus and this is minus, and this one's minus and this is plus. And then you also have one for tangent. So pay really close attention to the order of the A and the B, and to the pluses and minuses. Now, what this is really used for is like when you're going to have an angle like 75 degrees and you need an exact answer. And so you'd break that up into 45 plus 30. And then you can do sine of 45, you could do sine of 30 if you needed to, and so forth. So that's what it's used for. It's for getting exact values when it's something that you can put together, like 75 is 45 plus 30. Okay. So it's basically obtaining formulas that involve the sum or difference of two angles. Application problems, like word problems, involve a different quotient in calculus, a problem about electric power and geometry, like the angle between two lines. So if you did the word problems related to that, which are a little bit harder, that's what that is. So again, your objectives are to find and use the sum and difference formulas for exact values and identities, and to solve problems related to that. Now, when we say linear trig functions, that means like sine x, not like sine squared x. Okay, so consider angle A being larger than angle B, so that when you subtract, you get a positive answer. Also, that angle A overlaps angle B. So for example, if we have something like this, and then we have another one, you could say the whole thing would be angle A, and this part right here could be angle B, and so this one is A minus B, which is a positive angle. And then you'd also have ones like A is this one, and B makes it go to right there, and so then A plus B could be there. Like in the example I'm thinking about, you could say A is 30, B is 45, and so A plus B is 75, which is still less than 90. Okay, and then this is like what I was doing earlier with the formulas. If you have sine with addition of two angles, it's, when I was taught trig, she called it a song. It's really like a chant. It's like sine, cosine, cosine, sine, same sign, because if there's a plus there, there's a plus there, and first, second, because the A is the 1, the B is the 2. And then there's the one for cosine. It goes cosine, cosine, sine, sine, opposite sign, so the plus changes to a minus, and then first, second. So again, these are used because you can make your A to be 30, 45, or 60, which you know the exact value from the unit circle. The difference formulas are very similar. They're just like, if it's cosine, it's opposite. If it's sine, it's the same. So be careful if you have a similar question. And you can read through the description. We are going to have some where you have to establish the identity, which is like a proof. Just remember, sine and cosine are the same graph except for translations. Here I give you a hint that you can split up an angle like 75 into 45 and 30, then use the formula, and then use the exact value. So no decimals on that. On some problems, you're going to have to use radians instead of degrees. And so instead of using pi fourths and pi thirds, you need pi twelfths. And so like you would break up pi twelfths into 3 pi twelfths, which is the same as pi fourths, minus 2 pi twelfths, which is the same as pi 6. So that'd be pi fourths minus pi 6. And then you do your sine or cosine formula and find your exact value. On some problems, you're going to be given a fraction and an interval, like 0 to 2 pi, for example, and then need to see what quadrant you're in, and then do the Pythagorean theorem like we did before. Some problems are just like establishing your identities like we did before. It's like proofs or justifying steps. You have to show work when doing these problems. I think in yours, since it's multiple choice, for some of them it's going to be a little bit easier. So this part about skipping is not really accurate. It was when you had to do it by hand to do all the work. But we're still going to have those problems. Now there are some tangent formulas that are listed here also, but there's no song or chant for them. Okay, so what I mentioned earlier, if it's linear trig, it doesn't mean it's a straight line. It just means it's sine, not sine squared. The other thing I noticed about this when I did it before was you need to see if any solutions are extraneous or they're called extra. So that's going to be a little bit harder. Like saying it would work maybe algebraically, but if you graph it, it's not truly an answer. Okay, so let's get started. Now on this one, it's just a review type problem. It's problem 1 about using the distance formula. This is something you'd have to do in college algebra. And so you use your distance formula. Just like that. Okay, so on this one, you subtract your x values, square it, and subtract your y values and square it. They tell you the numbers, and so it's pretty easy to work with that way. You don't just want to count and estimate, because as you can see, you need an exact answer. Like sometimes you have square roots, and you got to simplify it. So this would be like 3 minus a negative 1 squared plus 6 minus 1 squared, and do your square root of that. So that'd be like the square root of 3 plus 1, which is 4, squared, plus 6 minus 1, which is 5, squared. So then that's 16 plus 25, which is 41. So we don't want a decimal equivalent. Now here's a couple of other review type problems. Remember, the problem is just listed twice. You can ignore the top part and see it here. So if you're doing the sine of pi fourths, well, remember your ordered pair xy goes cosine comma sine. And if we do sine of pi fourths, that's going to be square root of 2 over 2. And if we do cosine of pi fourths, that's the same thing. You can get that from your unit circle. So go to your unit circle, go to pi fourths, and there's your square root of 2 over 2 for both. So then if you have that, then you multiply straight across, because there's no equal sign in between. It's a times sign. So you go square root of 2 times square root of 2 is 2. 2 times 2 is 4. And always reduce your fractions. Because if you put 2 fourths, they'd probably count it wrong. And then if you look at the details, it says, although your answer is equivalent to the answer, you need to reduce, or something to that effect. Now also remember, if you have tan, that'd be like sine over cosine, which is like y over x. So for this one, for pi thirds, for cosine, that's going to be 1/2. So we put a half minus. Then we do tan of pi fourths. So for tan of pi fourths, that'd be sine over cosine. If it's the same thing and you're dividing, it'll just be 1, because both of these are positive. So then you're doing a half minus 1, which is negative a half. You can either do that on your calculator or get a common denominator. Now, what you notice about some of these is you could have, like, since I don't give you assignments at this time, that I collect your calculators and then you do some problems and then I give it back to you, that technically you could have just typed it, made sure you were in radian mode, the reason for radian mode is because it's pi. Make sure you're in radian mode and type it. Like, I'll just do the bottom one. At the moment I am in radian mode, and then I can go trig cosine pi over 3 minus trig tan pi over 4. And I do that as a decimal, and it gives me negative a half. On my calculator, it also would make it like that. Not sure about yours. But you can recognize negative 0.5 as negative 1/2. Okay, the next one is about like what is the formula? And so if it's cosine, the main thing to remember is it's the opposite sign. SIGN. And so this is plus, and so this has to be minus. And that's all that problem is. So some of these are going to go quick, just not all. On this one, it's another formula, and it's a minus here. And the formula for sine says to stay minus. So again, if you want to look sine of A minus B, then that's the minus. Now, here's where it's starting to get a little more difficult, starting with problem 13. So the start of it is we have pi 12ths. Well, just the first thing is pi 12ths does not show up anywhere on here. My approach would be figure out what the decimal is, because to me it's easier to figure out with decimals than radians, like what the degrees are. Use degrees instead of radians. But if you'd rather do the view an example and do it that way, that's fine. Just whatever works. So my recommendation, I recommend using degrees. And so we would do our 180 divided by 12 to figure out what that is. Because pi 12ths is equivalent to 180 12ths. And we go 180 divided by 12, that's 15. Okay, well I know I can make 15 by doing 45 minus 30. So that's how I would think about it to begin with, and then switch to radians. And so I'd think of that as pi 4ths minus pi 6ths. Remember, if you substitute 180 for pi, then 180 over 4 is 45, 180 over 6 is 30. So what this changes to is cosine of pi 12ths is equivalent to cosine pi 4ths minus pi 6. And then you write your formula. Okay, it's a cosine, so it goes cosine, cosine, sine, sine, opposite sign. So we change the minus to a plus, and then you do your first second, or you could call it AB. Pi 4ths, pi 6, not negative pi 6, careful about that, and then pi 4ths, pi 6. So then cosine of pi 4ths is square root of 2 over 2. Cosine of pi 6, you go to pi 6, go to cosine, it's square root of 3 over 2. Sine of pi 4ths is square root of 2 over 2. Sine of pi 6 would be a half. And so then you multiply straight across, and square root of 2 times square root of 3 is square root of 6, and 2 times 2 is 4. And then for this one, square root of 2 times 1 is square root of 2, and then 2 times 2 is 4. And then what you do is get a common denominator, and that'd be acceptable, or 1/4 square root of 6 plus square root of 2. You can't reduce square root of 6 because you can't use a 9 or a 16 or a 25. Now, some problems are going to have a minus. Some problems are going to put the other number in front. So there are a variety of problems. It's not the same answer every time. Now on this one, we're using sine of 75. And so we break that up into sine of 45 plus 30. The order doesn't matter, but for sine, we would then do sine, cosine, cosine, sine. Okay, so I'm doing the sine of a plus. So sine, cosine, cosine, sine. And then I'm doing the same sign. So if this is a plus, this is a plus. And then first, second, first, second. So square root of 2 over 2, cosine of 30 is the x, which is square root of 3 over 2. Cosine of 45 is the same, square root of 2 over 2. Sine 30 is also a half. So it turns out that when we do this, we get square root of 6 over 4 plus square root of 2 over 4, which was the same answer as the other one. Notice we don't do nested square roots. No nested square roots like square root of 6 plus square root of 2. So we don't do anything like that. So be careful if you're typing it, because you'd have to do it separate like that. So what that means is that cosine of 15 is equal to sine of 75. That's actually a concept, because if you do 90 minus 15, you do get 75. And so cosine and sine of corresponding values are equal. And so what we did just there is we, where is it? What we did right there was we split it into the others. Okay, so that was one of our goals. Our goal was to say, I think it's called, it's not coterminal, but it's like adding two angles to 90, which means complementary. And then change the trig functions. Change trig from sine to cosine, etc. So that's our concept. Now in our next one we have tan of 75, and so that'd be tan 45 plus 30. So tan of 45, well, remember that we're not distributing, so don't ever think of that in this case. We're not distributing. You need to use your formula. Use the force. Okay, so for tan of a plus b, our formula is tan a plus tan b over 1 minus tan a tan b. So that'd be like tan 45 plus tan 30 over 1 minus tan 45 times tan 30. So tan of 45 is 1, because remember the x and the y are the same. For 30 degrees, that ordered pair is square root of 3 over 2 comma a half. And so if you're doing tan, we're just going to say it's 1 over square root of 3. And then 1 minus tan 45, again, we said is 1, times the tan of square root of 30, or tan of 30, which is 1 over square root of 3. So if you have a problem like this with a square root in the denominator, if a square root is in the denominator or a fraction over a fraction, then simplify. So in our case, multiply all by square root of 3, because square root of 3 is in my denominator right there. So if I multiply every term by square root of 3, that'd be, this is square root of 3, this one is 1, because square root of 3 times that cancels. This one's square root of 3 minus this one is 1. So then you have this, which is probably equivalent to this. I'm going to check that as a decimal. 2 plus square root of 3 as a decimal is 3.73, and square root of 3 plus 1 over square root of 3 minus 1 is the same thing. Now, let's see what happens on the teacher calculator. That did simplify it, but I know y'all's doesn't do that. So to get that, I'd say Math Excel should accept it. If not, then do your rationalizing. If not, then I'm going to say rationalize. And so what we do is we say square root of 3 minus 1 on top and bottom, multiply straight across and do FOIL, 3, and then minus 1, and then 3 minus square root of 3 minus another is minus 2 square root of 3, and then plus 1. So that simplifies to 2 over 4 minus 2 square root of 3. And then that would simplify to the other one. It's a lot of extra work. I don't think it's worth it. We could probably factor out a 2 to our denominator, and then cancel this, and so that's 1 over 2 minus square root of 3. That still didn't really help that much. So maybe we should have I should have multiplied by the positive. Okay. I should have multiplied by the positive. Use positive instead. So this right here was a mistake. So we want to do square root of 3 plus 1 over square root of 3 minus 1, and then change it to plus for it to cancel. So we get 3 plus 2 square root of 3 plus 1 over 3 plus 1. That gives us 4 plus 2 square root of 3 over 4, and then those can cancel into 1 plus square root of 3 all over 2. So 1 plus square root of 3 over 2, and Again, that would probably be counted right also on Math Excel. And if you multiply by 2, then that would definitely get it. So there are a few different versions of it. Like you could probably use this, you could probably use this, or you could use the exact right there. Those all decimals would be acceptable. Okay, so I'm going to stop right there for that video. Hope that helps.